Okay, pre-calculus. These are the notes for 4.1 and 4.2. Our main focus in this video, I'm probably going to have to cut this into a couple parts again. This first video is going to mainly focus on radians and how we know the radian angles, because we need to eventually understand the radian angles without using our unit circle. But before we get to that, we want to think of angles as having an initial side and a terminal side. And the standard position for an angle is to have its initial side on the positive x-axis. Positive x-axis. So our angles will always start with the initial side on the positive x-axis. The terminal side is basically just going to be the final position. And this can be in any quadrant. We'll figure out which quadrant it's in by the angle. So if, for example, I said to draw the angle 130 degrees, I would start off with my initial side always on the x-axis. And then 130 degrees is more than 90. It'd be somewhere over here in the second quadrant. So this would be an angle of 130 degrees. If I said to draw the angle negative 130, I still would have my initial side on the positive x-axis. A negative angle just rotates the other direction. So a negative 130 would land me somewhere down in the third quadrant. That would be negative 130 degrees. So positive angles go counterclockwise. Negative angles go clockwise. So we're used to not thinking that negative angles can happen, but they just mean rotate the opposite direction. On Blackboard, we have the unit circle and then a filled in unit circle. We'll talk about the filled in one in the next section of notes, or the next couple sections. But for right now, actually, let's go to here. There we go. I want to focus on the unit circle and its angles. So a couple things. Unit circle is a circle with a radius of 1 unit. That's why it's called the unit circle. So that's why this is going at 1, 1, negative 1, etc. The unit circle is basically going to be a tool for us to calculate the value of trig functions without needing an actual calculator. Now, it only works with the special angles, and the special angles are increments of 30 and 45. Technically 60 as well, but 60 is an increment of 30, so it's really included in that. Now, in terms of degrees, you can see that this rotates all the way around, all the degree angles for these special angles. So the blue ones are incrementing by 30. So 30, 60, 90, 120, 150, etc., all the way around. The red angles are incrementing by 45 degrees. So 45, 90, 135, 180, etc. So in the degrees, not a huge deal. Just have to keep adding. What I want to focus on is this idea of a radian angle. I posted a very short video. It's actually not my video, but it explains what a radian is. A radian angle is basically if I were to take the radius, and again, I have a short video that I posted that explains this a little better. If I take the radius and I were to wrap that radius around the circle. So I pluck the radius and I imagine it like being a string that I could wrap around the circle. The angle that makes is 1 radian. To give you a bit of an equivalence, it's around 57 degrees. So it's actually not very comparable to degrees. It doesn't fit nicely. But where it does fit nicely is, and again, this is on the video, the formula for circumference is 2 pi times the radius. Well, 1 radian is just the radius wrapped around. So what that means is the angle measures all the way around a circle is 2 pi radians. So whereas it's 360 degrees to go around a circle, in radians, it's 2 pi, a very different number. And remember that 2 pi is just a number. It's not, pi is not a variable. 2 pi is around 6.28. So it's just basically comparing the number 6.28 to the number 360. So it's just another way to measure angles. It actually makes a lot of calculation easier, and it's a more logical way to measure angles, actually. Had we had class time for this, I had lots of interesting little ways to describe it, but unfortunately we're stuck with this. Now, what I want to talk about for pretty much the rest of this video is how do we get all these radian angles, the pi over 6, the pi over 4, the pi over 3. You can just memorize all of them if you want, which is fine, but I don't think that's the best option. If I know that a full circle is 2 pi radians, it makes sense that if I slice the circle in half, then I'd slice 2 pi in half, and it's pi radians, which you can see is already marked on there. If half of a circle is pi radians, and I divide that in half, half of pi would be pi over 2 radians. Now, the next thing I'm going to do is slice the pi over 2 in half. Half of 90 degrees, or pi over 2, well, half of 90 is 45. Well, half of pi over 2, if I slice that in half of a half is a fourth. So that's where pi over 4 radians comes into play. I'm going to focus just on the red stuff, just the 45 increments right now, and we'll jump back and worry about the 30s and 60s in just a second. Here's my proposal. If you know that, if you know that 45 degrees is pi over 4 and you can count, then you can get all of the 45 increments going around. So 45 degrees, think of it as 1 pi over 4. Then the next 45, which is up at 90 degrees, would be 2 pi over 4. But that reduces to pi over 2. If I can just keep counting, the next 45 was 3 pi over 4. The next one would be 4 pi over 4, which is just pi. The next one's 5 pi over 4. 6 pi over 4, which again is reduced to 3 pi over 2. 7 pi over 4. And then all the way back around would be 8 pi over 4, which is also 2 pi. So basically the keystone is, if you know that 45 degrees is pi over 4 radians, as long as you can count 1/4, 2/4, 3/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, you can get all the way around the circle. Now for the 30, 60, 90s, oh no, that did more than I wanted. Let me pause real quick. All right, got it back. So now let's look at the 30 degrees. And remember, the 60 is just an increment of 30. Let's go back to the idea of pi over 2. So from pi over 2, that's 90 degrees again. To go from 90 down to 30 degrees, I'd have to divide by 3. So if I take pi over 2 and I divide that by 3, that is pi over 6. If you know that 30 degrees is pi over 6 radians, or let me say it as 1 pi over 6 radians, and you can count, every increment of 30 is just going to be another pi over 6. So 30 degrees is 1 pi over 6. The next increment would be 2 pi over 6, which reduces to pi over 3. The next would be 3 pi over 6, which is pi over 2. The next would be 4 pi over 6, which reduces. 5 pi over 6. You can see anytime I'm going to get a fraction that can reduce, I would. But again, all I'm doing is counting by 1/6 every time. So 7 pi over 6, 8 pi over 6, which reduces. 9 pi over 6, which reduces. 10 pi over 6, which reduces. 11 pi over 6, and finally 11 pi over 6. But then I finish with 12 pi over 6, which is 2 pi. So if I know that 30 degrees is pi over 6, and I can count 1/6, 2/6, 3/6, 4/6, 5/6, 6 over 6, 7, 8, 9, 10, 11, 12. Again, if I can do that, I can get all of my pi over 6 30-degree increments. So instead of thinking of it as memorizing this huge unit circle, and memorizing all of these radian angles individually, start at either 1/6 or 1/4, depending on what kind of problem you're dealing with, and just count. And that's what I'm going to do pretty much every time we do one of these problems, which again, we'll get into more in the next section. So if you watch that short video, back to our regular notes, it mentioned that pi radians is 180 degrees, which again, we saw a half rotation is pi radians. I can use that as a conversion factor to be able to convert from radians to degrees and back and forth. So what I mean is, for number 1, A, B, and C, if I want to convert these to degrees, think of it like when you would multiply by something like 12 inches is 1 foot to convert units. Same exact idea here. If I want to convert a radian to degrees, I'm going to multiply by 180 degrees over pi. That's a degree symbol. Note that the pi's cancel, and really this becomes 180 over 10, and it is negative. So this would turn into negative 18 degrees. Same logic on letter B. I'm going to times it by 180 degrees over pi radians. The pi's cancel. 5 can reduce into 180 36 times. 2 times 36 is 72 degrees. So this is a good little tool to have in your belt if you're going, oh, I don't remember what this radian angle is in degrees. Just multiply it by 180 over pi. Pi's cancel. 15 goes into 180 12 times. This becomes 7 times 12, 84 degrees. On number 2, A and B, to go from degrees to radians, we're just going to flip that conversion factor. Basically, the units of degrees are canceling. Now, you could put this in a calculator, but I want to leave it in terms of pi. So instead, I'm going to just reduce. 15 goes into 75 5 times. 15 goes into 180 12 times. So this becomes 5 pi over 12. That is a 5. Usually we don't write anything for radians. There's no symbol like there is for degrees. We just have to know that that's a radian measure. Same logic on letter B. I'm going to multiply by pi over 180. And essentially, I'm just going to reduce. Let's see. 20 goes into 160 8 times. Goes into 180 9 times. So this turns into negative 8 pi over 9. Okay, we'll stop this video here. We'll worry about the special right triangles on the second video of this.